All right, I'm going to talk about Chesapeake Bay nutrient issues. The biggest thing to hit the nutrient scene in terms of regulation these days is the TMDL, or total maximum daily load. And this is EPA's hammer after years of voluntarism that didn't really effectively change the nutrient loads. The regulatory approach has been instituted, and it goes through these phases. First, identifying impaired waters, and essentially the entire Chesapeake Bay and its tributaries are declared impaired for nutrients and sediments. Develop TMDLs, which are defining the pollution goals, and that's using the watershed model, which I'll talk about in a little bit, and implement watershed management actions. This is done through a watershed implementation plan, or WIP. Each state has their own WIP, which gets approved by EPA. Needs approval by EPA, and then the progress is monitored and adjustments occur. So the process is taking these different inputs, these different best management practices, using a land use map, and then the various point sources and then non-point sources to drive a watershed model, which then determines how much nitrogen, phosphorus, and spent sediments is coming off the watershed into the bay, and then the bay model that then processes those nutrients and turns it into dissolved oxygen, parameters, and other chlorophyll and the other predictors that model generates. And then the idea is that's iterated till you get the loads allocated so that you achieve the water quality standards that are being set, and then that gets adjusted. So that's the kind of process. So lots of reliance on both the bay model and the watershed model, and those factors that influence the best management practice effectiveness. So overall, the nutrients in the watershed are dominated by non-point sources, diffuse sources. So in terms of phosphorus and nitrogen, there are significant wastewater discharge sources, but it's much smaller than the diffuse sources. And the ag inputs are dominated for phosphorus or animal manure waste, and for agriculture, it's the fertilizer. And nitrogen has a large atmospheric component that phosphorus does not. Loads differ geographically, and if you look at the size of the bar, you see that the total amount of nutrients from the Susquehanna and the Potomac dominate, and that's because of the large size of those watersheds. But the proportion changes. In the Eastern Shore and the Susquehanna dominated by agricultural sources, the beige color. But then as you get into the Washington-Baltimore area, it's point sources dominated, and then a mix in the Virginia tributaries. When we take the TMDLs and plot them out on a map of the watershed, what we see are trends for nitrogen, phosphorus, and total suspended solids. And the urban and agricultural lands pretty much dominate where the nitrogen phosphorus sources are. You see the urban corridor with high reductions required in the Susquehanna watershed for N and P, but for total suspended solids, it's more of a geographic map of the Piedmont and Ridge and Valley, where the sources of sediments are more pronounced. And you can see that the phosphorus tends to track the total suspended solids a little more closely. For example, the Eastern Shore has got relatively lower percent reduction required because of the low relief and the less runoff. Now, in terms of the best management practices, cover crops are really being pushed as a major effective way to remove nitrogen. So basically a fallow winter cornfield, all that leftover nitrate that doesn't get absorbed during the summer by the corn plants then leaches into the groundwater unless you plant a cover crop like the rye here. And then Russ Brinsfield and Ken Staver at the Y Research Institute here on the Eastern Shore have looked at the shallow groundwater nitrate over time in some experimental fields, large experimental fields, and they see that all these other best management practices they use with the type of injection and of nutrients and riparian and all that. Without a cover crop, you really don't see an improvement. But with cover crop, after a few years, with either conventional or no-till ag, you see a dramatic decline. So you need like 3 successive years of cover crops, and then you start seeing a really good decline, and then but the full decline takes 8 or years or more. Now, the other difference here is that so nitrate as a form of nitrogen comes through in groundwater. Phosphorus is a different story, and this phosphorus budget for the entire Delmarva Peninsula takes into account the total amount of fertilizer imported, the total amount of sewage sludge applied to the fields, the amount of corn that's imported to feed the chickens, and any supplemental phosphorus for their production, and then takes out the poultry litter, that is the manure from these chickens, which is applied to the crops, and then what gets taken out of the ecosystem by the grain that we export, and the chickens that we export from the system. Well, if you just do this as a total balance, you see the total inputs, 8 kilograms, and that's 1,000,000 kilograms of per year of phosphorus, is about 4 is retained, and so and 3 is exported. Well, it's retention that we have to worry about. So there's a buildup of phosphorus, and since phosphorus doesn't have a volatile like denitrification, removing nitrogen, doesn't have that equivalent biogeochemical pathway, we build up phosphorus, and they estimate about 20 years worth of phosphorus on the soils. So the agricultural nutrient issues and management options are really different depending on the type of nutrient, nitrogen versus phosphorus. And we can also get into the fact that different species of nitrogen have different implications as well. But overall, the idea that there are these nutrient issues which have to do with poultry production and the application of manure, the application of fertilizer, the type of agricultural practice, no-till or till, affect the amount of nutrients making it into the water, and the major management options that have been implemented are cover crops and subsurface injection manure, and then trying to use cover crops to absorb the nitrate. So let's have a look at the data that determines whether or not we've made any progress on the watershed scale. First of all, these are USGS monitoring stations, and you can see the green little triangles pointing downward. Those are areas that are improving nitrogen trend. In other words, those concentrations are going down, and you can see that's pretty ubiquitous. There are some areas in the little yellow that aren't changing, but only a couple that are actually increasing. One in the Shenandoah and another in the York River, but otherwise we're seeing some good reductions. Now that should be a good news story, but when we look at the data from the bay and the tidal tributaries, it's not as ubiquitously a good news story. We actually see lots of these areas in which we get degrading trends, and we see it in the York, we see it Choptank, Nanticoke on the Eastern Shore. We don't have many stations on the Eastern Shore currently. They're trying to get more. The Patuxent has a bunch of degrading trends. After initial success, it's starting to degrade, and down at the James River. So we've got some problems that we're starting to see in terms of the nutrient trends that are manifested at the tributary level. The one place where we can really point to that shows demonstrable success are these large-scale sewage treatment upgrades. And these are expensive business, but hundreds of millions of dollars for those big triangles. The one in Washington, D.C. is Blue Plains. The ones in Baltimore are the Back River. And those are expensive, but have demonstrably good results. We've seen resurgence of grasses and water quality associated with those. Now, one of the things that you'll be hearing a lot about now is nutrient trading. This has been promulgated by the EPA, and it's defined as an innovative approach to achieve water quality goals more efficiently. And I want to point out the reason I chose to copy this text out of the EPA guidelines on water quality training is is that they're fairly emotive. They're very positive. They're saying it's an innovative approach. It's 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 it allows achieving the same water quality improvement and lower overall costs. So they're promotional in the sense of the way they're approaching it. And each of the states then has a nutrient trading plan, and equally emotive language occurs. So, and several of us looked at this. I served sort of a mediator between some river keepers who are very anti-nutrient trading and some of the agencies which are pretty pro-trading. We came up with this sort of plus and minus table. So the pluses of nutrient trading is it can unleash free market force instead of a regulatory top-down approach that allows innovation and a bottom-up. It avoids the regulatory innovation, provides additional tools for regulation. It is embraced by various key stakeholders. It provides mechanism for distributing funding from the farmers, so as the urban upgrades, which cost hundreds of millions of dollars, can be promulgated to the farmers. We can get more, and things like cover crops, we might be able to get more bang for the buck, so to speak. And it's been shown as a good model for management in the air realm. So they put caps on the sulfur dioxide or NOx, and then factories can trade off their outputs using a cap and trade scheme. Now, the negatives of this is that it's independent and rigorous verification is very difficult. Ecosystem services other than nutrients should be considered. So planting a riparian buffer, for example, provides wildlife habitat and corridors and all kinds of amenities other than just nutrients, and so those don't get factored in. It also promotes large organizations and corporations versus a grassroots entity. So they have this bundling approach where these large organization will work with a suite of small farmers and bundle them. There are also environmental justice issues, moving the problems to poor areas. And the previous success in air quality may not translate to water. Water is a much more viscous medium, and so what you do in one place matters a whole lot for that place, might not translate to somewhere distant from that. So key elements needed for effective trading are incremental baseline, is that the water quality baseline needs to be met before the trading can occur. So you don't want it to be used to trade down so that you end up accepting a lower water quality standard. You need full offsets. The remediation of the entire ecological footprint is needed. And you need a net improvement credit. So account for unknowns using a safety margin. People argue what the trading ratio should be. So between 2 and 3 is often argued. You need 2 to 3 units of nutrients gained for every nutrient unit of nutrient traded, so that it can account for those differences. So that's, and you'll be seeing a lot about nutrient trading, I think, in the next few years. So that's a broad overview of some of the nutrient issues in Chesapeake Bay.